morning all. I am Praveena, Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. In this session, we will discuss about the problems of Gauss Divergence Theorem. Gauss Divergence Theorem is related to the vector calculus. Okay, what is the use of Gauss Divergence Theorem? Already we discussed in the previous sessions. That is transformation between volume to the surface integral, right? Transformation between volume to the surface or surface to the volume. Okay, let us start with the first question. That is, verify Gauss Divergence Theorem for f bar is equal to x cube minus yz into I bar minus 2x square y into j bar plus z k bar taken over the surface of the cube bounded by the planes x is equal to y is equal to z is equal to a and coordinate planes. Okay, where we have to verify the given function f bar, we have to verify over the surface of the, what is the surface form here? Cube bounded by the planes. What are the planes here? That means x is equal to y is equal to z is equal to a, that are all called on coordinate planes, right? By Gauss divergence theorem, what is the statement of the Gauss divergence? Integral s f bar dot n bar ds is equal to integral v divergence of f bar dv. What is the main use of this theorem is transformation between surface to volume or volume to surface. That means double integral to triple integral or triple integral to double integral form. If you have to solve these two, if LHS and RHS both are equal, then the given question Gauss divergence theorem is verified. Okay, now the procedure for this question. Given function as, what is the given function? F bar is equal to, I'll write here, f bar is equal to x cube minus yz into I bar minus, this is minus 2x square y into j bar plus z into k bar. This is the given question. And what are the limit points for that? Here, the function is over the surface of the cube bounded by the planes. Okay, what is the diagram of the cube? Okay, before going to draw the diagram, first I'll calculate the triple integral form from the question directly. Here, what are the points for x and y and z? X and y and z are 0 to a, and x limits are 0 to a, and y limits are 0 to a, and z limits are 0 to a. Okay, first I'll calculate by using Gauss divergence theorem, I'll calculate first RHS part. From that RHS part, what is the RHS part of the theorem? That is integral of divergence of f bar dv. Okay, from that first I'll calculate divergence of f bar. Okay, what is divergence? Divergence means here I'll write divergence is equal to I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z. And what is f bar here? X cube minus yz into I bar minus 2x square y into z bar plus z into k bar. Okay, now this is divergence of f bar. The two are in the vector form, right? Divergence also vector form and f bar is also in vector form. Now the product of or dot product of divergent and f bar means here I bar coefficient is dou by dou x and there I bar coefficient is x cube minus yz plus here j bar coefficient is dou by dou y, here j bar coefficient is 2x square y. There k bar coefficient is dou by dou z, here k bar coefficient as z. Okay, from that first I'll differentiate with respect to x. That is x cube minus yz means the differentiation is 3x square. With respect to x means yz zeros, right? And next with respect to y, What is the differentiation of with respect to y? This has 2x square y means with respect to y 2x square as constant and y differentiation as 1. That is 2x square into 1 plus dou by dou z of z differentiation as 1. That is 3x square. Okay, here minus 2x square minus, that is minus, that is 3x square minus 2x square plus 1, that is equal to x square plus 1. Therefore, what about divergence of f bar? Divergence of f bar is equal to x square plus 1. Okay. Now, substitute each and every value in the RHS of the Gauss Divergence Theorem, that is divergence of f bar dv. This is equal to what? dv means triple integral of divergence of f bar means that is x square plus 1 into dv means what? dx dy dz. And what are the limits for that? 0 to a, 0 to a, 0 to a. That is this one. Okay. Now first integrate with respect to z. Okay, now here first integrate with respect to z, that as integral of 0 to a, 0 to a x square plus 1 with respect to z means I'll consider x square plus 1 as the constant and dz integration as z. And what are the limits for that? 0 to a and dx into dy. Okay, next dx into dy, that is equal to integral 0 to a, integral 0 to a x square plus 1 into z integration. After z integration, now substitute the limits. A is upper limit, 0 as the lower limit into dx dy. That is equal to integral 0 to a, integral 0 to a into x square plus 1 into dx dy. Okay. Here after that I'll integrate next with respect to y. That is a into integral 0 to a x square plus 1 into, okay, y integration, that is y. And what are the limits for that? 0 to a dx. 0 to a dx, that is equal to a into integral 0 to a x square plus 1, y upper point as a and the lower point as 0 into dx. Right? That is equal to, here a I'll take outside, a into a square, and the last different integration is with respect to x, right? That is x square integration as x cubed by 3 plus 1 integration as x, and the limit points are 0 to a. Okay, that is equal to a square into upper point as a cube by 3 after substituting a in place of x cube, that is a cube by 3 plus a, and substitute the lower limit, that is 0. Okay, that is a square into a cube, that is a power 5 by 3 plus a cube, that is integral of divergence of f bar. Once you see here, the procedure is first integration with respect to x. Here with respect to x or y or z, whatever it is, here we got the same answer. Why? Because here, okay, limit points are, all limit points are 0 to a only. For that case, here integrate either with respect to x or y, integrate with respect to y or z. In that procedure, first integration is with respect to x, after that integration with respect to y, here after the integration is with respect to z. For that case also, here we got the same answer, that is a power 5 by 3 plus a cube. And here what I done here first I'll integrate with respect to z, and after that integration with respect to y, and after that integration with respect to x. Then for this procedure also we got the same answer, a power 5 by 3 plus a cube. Okay, let us take after the integration with respect to x, y, z, then the final answer let us assume that as the first equation. Therefore, from the Gauss Divergence Theorem RHS part, integral divergence of f bar dv is equal to how much? A power 5 by 3 plus a cube. Okay, this is the first part of the theorem. Next, I'll verify the LHS part with corresponding to through the question. Okay, through the question conditions. Okay, next step. Okay, next part of the answer here, verification. How to verify? Here some conditions are there in the question. What are that conditions here? That the function is over the surface of the cube. Okay, it passes through the surface of the cube. The coordinate planes are x, y, z is equal to a. Okay, from that here the surface is, okay, that the surface means what here? Cube. Cube means how many faces? 6 faces. Now we have to calculate the surface integral and surface integral on each and every face of the cube. Okay, na? That means here cube is having 6 faces. Now we have to calculate that 6 faces answers. Then add all the values. If you got the same answer compared to the RHS answer, if both the answers are equal, therefore the Gauss divergence theorem is verified for that first question. Okay, that means verification. How to verify? We will calculate the value of integral s f bar dot n bar ds over the 6 faces of the cube. Particularly what they are given here, particularly cube. What they are given? Cube. That surface of the cube bounded by the planes are x is equal to y is equal to z is equal to a. For that first, I'll draw the diagram for that cube. That is, this is the diagram. That is three-dimensional space. This is 6 faces of the cube. From that, here once you observe, from the diagram here, 6 faces, 2 are in the x-axis, 2 are in the y-axis, and 2 are in the z-axis, right? Okay, 2 are in the x-axis, 2 are in the y-axis, and 2 are in the z-axis. What are that? X is one face is on positive direction, one face is on negative direction, and another one is positive and another one is negative. Similarly, in z is also one is positive face and next another one is negative side of the face. For example, if we are calculating on x face, that means s1 face. Here how many faces? 6 faces. I'll assume the first face here. This is the first face. What is that? PQAS. PQAS. It is on x-axis, right? PQAS is on x-axis. Okay, from that unit normal vector. What is the unit outward normal vector? Which is in the positive direction of the x-axis. That's why I'll take that as n bar is equal to I bar. Okay, that means here whatever the next face of the x-axis, that is in the negative side of the x-axis. That means PQAS. Opposite one is what? Opposite one RCOB. RCOB. That means first phase is S1 PQAS and the second phase is RCOB. And what about the third phase here? Third phase RBQP. 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 Where is it once you observe? RBQP, which is on the z-axis, right? RBQP. Okay, and what about the fourth phase? That opposite one, that is OACS. OACS. And what about S5? 2 are in x-axis, 2 are in z-axis. Now I'll write the last one. S5 and S6 are in the y-axis. What are that? 2 are PCSR and the last one here S6 as OABQ. These are the 6 phases. 2 are in x-axis, 2 are in z-axis, and 2 are in y-axis. Okay, now we have to calculate each and every surface integral value. Okay, and after that add these 6, that is S1 plus S2 plus S3 plus S4 plus S5 plus S6. If you are adding the 6 phases values, that is equal to the Green's theorem RHS part answer. If both the answers are same, then the given question Gauss divergence theorem is verified. Now I'll start with the first phase. Here from the diagram, first phase is S1 is equal to PQES. From that, what is unit outward normal vector? Okay, that is positive side, that is n bar is equal to I bar. N bar is equal to I bar. And what about that coordinate points? That is here from x-axis, here x is 0 to a. Okay, from that here y is also 0 to a and z point also 0 to a. That means here I'll take x point is a, that unit normal vector is n bar is equal to I bar. And what about ds? Here ds means what? ds is equal to dy dz by, okay, modulus of n bar dot I bar. Right, from that dy dz by modulus of I bar dot I bar. I bar dot I bar value how much? 1. That's why directly we can consider ds is equal to what? dy dz. We are calculating on, okay, surface integral on yz axis means then we can take the limit points on y and z. What are the limit points on y? That are 0 to a, and z limit points also 0 to a. Okay, from that, okay, now I'll calculate the surface integral on, okay, first phase, that is S1 is equal to PQAS. From that, first I'll take dot product with F bar dot N bar. What is F bar here? F bar is x cube minus yz into I bar minus 2x square y z bar plus z k bar. This is F bar. This is multiplied with n bar. What is n bar here? That is outward unit normal vector I bar. Then dot product with both the vectors, that is x cube minus yz. This is I bar quotient for the first vector, and n bar vector is I bar, that quotient as 1. Therefore, this is x cube minus yz. Therefore, f bar dot n bar is equal to how much? X cube minus yz. But from the conditions here, what is x? X is equal to a. I am substituting here, that is a cube minus yz. Okay, therefore double integral of, that is s f bar dot n bar ds is equal to what? Double integral of f bar dot n bar into dy dz. Okay, that is double integral of what is f bar dot n bar here? A cube minus yz into dy dz. And what are the limit points for y and z? Well, limit points are 0 to a, and z limit points also 0 to a. Okay, now I'll integrate first with respect to y. Okay, next step I'll integrate with respect to y, that is a cube y minus y integration as y square by 2 into z. Okay, then substitute the limit points 0 to a, and the remaining part as integral z is equal to 0 to a dz. From that substitute the limit points, that is 0 to a cube into a minus a square by 2 into z. And after substituting the limit point, lower limit of y, that as 0 into dz, right? That is equal to integral 0 to a power 4 minus a square by 2 into z dz. Okay, now integrate after with respect to z. Integrate with respect to z, that as, okay, a power 4 into z minus a square by 2 into z integration as z square by 2. And what are the limit points for z? 0 to a. that is equal to, now substitute the limit point, upper point of the z, that is a power 4 into z as a, minus a square by 2 into a square by 2. Now substitute the lower point, that is 0. Directly this is 0. Therefore, a power 5 minus a power 4 by 4. This is the first phase S1 answer as a power 5 minus a power 4 by 4. Let us take that as the second equation. Next, okay, now first phase S1 PQ is on x-axis positive direction. From that we got answer as a power 5 minus a power 4 by 4. Now I'll take the second one. S2 is equal to OCRB. OCRB is a, okay, negative side of the x-axis. For that side, unit outward normal vector is what? N bar is equal to minus I bar, right? N bar is equal to minus I bar. From that, x point is what? Already we discussed on diagram. X point passing through the 0 to a. Where is it 0? 0 is on the negative side of the x-axis. That's why I'll consider negative side. X is equal to 0. What they are given in the question, x points are x, y, z is equal to a. And whatever the lower limit for that initially starts from, that as 0. That's why directly we can take x-axis, okay, x-axis negative side as 0. X-axis negative side, x is equal to 0 and ds is equal to what? ds is equal to dy dz. And what are the y limit points? 0 to a. And z limit points also 0 to, I'm sorry, y limit point 0 to a and z limit points also 0 to a. Here 0. Okay, z limits are 0 to a. Already we know that what is f bar dot n bar. In that previous phase only we got that f bar dot n bar is equal to what? X cube minus yz, right? X cube minus yz. From that, what is x here? What is x here? Directly x as 0 minus yz. Therefore, f bar dot n bar is equal to what? Minus yz. But here y limit points are 0 to a and z limit points are 0 to a. Here f bar dot n bar means n bar unit normal vector as minus I bar. That's why here we got minus. Okay, that's why here f bar dot n bar, product of these two vectors, we got minus of x cube minus yz, right? Minus x cube minus yz. Procedure is same for the previous phase, but here in place of n bar, just substitute minus I bar. After the product of the two vectors, we got the answer for that, a minus of x cube minus yz. But what is x here? 0. That is minus into minus plus yz. This is f bar dot n bar is equal to how much? Yz. When if you are substituting x is equal to 0. Therefore, double integral of f bar dot n bar ds is equal to double integral of f bar dot n bar ds is equal to z limit points 0 to a and y limit points 0 to a and f bar dot n bar as yz into dy dz. Okay, now first integrate either with respect to y or zy because both the limits are same only. Here for that, first I'll integrate with respect to y, that is y square by 2. Limit points are 0 to a and here z limit points 0 to a into dz. That is a square by 2 upper point a. Then we have to substitute there. We got a square by 2 and lower point as 0 into dz. Integral z is equal to 0 to a, that is a square by 2. Here a square by 2 and the remaining z equal to 0 to a, z into dz. Okay, now integrate with respect to z. That is a square by 2 into z integration is z square by 2 and the limit points are 0 to a. That is a square by 2 and a square by 2 minus 0 after substituting the limits. Therefore, it is a power 4 by 4. This is this. Let us take that as the third equation. Okay. Therefore, from the cube, second face of the cube S2, it is on x-axis, negative direction. For that answer, a power 4 by 4. Let us take that as the third equation. Next, I'll take the third phase here, RBQP. Once you observe the diagram, RBQP, where is it? RBQP, which is on z-axis, positive direction. Okay, z-axis positive direction. For that case here, unit normal vector is outward. Unit normal vector is n bar is equal to k bar. N bar is equal to k bar, and that limit point is this is also passes through the on z axis 0 to a. For that, here we are calculating on z axis positive direction. That means it passes through the 0 to a, means here the z limit point is a, and whatever the negative side of the z axis limit point 0. That means how it will pass as 0 to a. First negative direction, after that it passes through the positive. That's why in that positive you have to take the last limit, that is a, end point of the limit, that is a. That's why we'll consider here z is equal to a and ds is equal to dx dy and n bar is equal to k bar, and ds is dx dy means, okay, now I'll take the limit points on x and y. X limit points are 0 to a and y limit points also 0 to a. Okay, now I'll calculate f bar dot n bar, that is x cube. What is the function here? X cube minus yz I bar minus y square z into j bar plus z into k bar into what about n bar here? K bar. N bar is equal to k bar. Multiply both the matrices here. Okay, here n bar is k bar only. That's why here directly we got z. Z of 1. For the first vector, k bar coefficient as z. From the second vector, k bar coefficient as 1. That is z. Therefore, f bar dot n bar is equal to what? Z. But from the condition here, z is equal to what? A. Therefore, here f bar dot n bar is equal to a. Okay, therefore now integrate with respect to x and y. That is double integral of y is equal to 0 to a and x is equal to 0 to a into dx dy. A into dx dy. From that, first differentiate, integrate with respect to y. That is a into y, limit points are 0 to a, integral x is 0 to a dx. That is a into a minus 0 and integration of dx as x, limit points are 0 to a. That is a square into a minus 0, that is a cube. Okay, therefore surface integral on z axis, okay, that is a positive direction. That answer is how much? A cube. Let us take that as the fourth equation. Next I calculate, okay, fourth phase on z axis negative side. Okay, fourth phase on z axis negative side, that is S4. What is S4 here? OASC. Okay, OASC, that z limit point as 0. Okay, that z limit point as 0. Already I discussed in the previous phase, that is z is passes through the 0 to a. That means z0 is on the negative side of the z-axis. That's why I'll take the z limit point here 0 and the unit normal vector. What is the unit normal vector? N bar is equal to what? Minus k bar. Right? N bar is equal to minus k bar. Then what about ds here? ds is equal to dx dy. ds is equal to dx dy. Therefore, x limit points here, ds is dx dy means, then we can take x limit points on 0 to a and y limit points 0 to a. Then multiply f bar dot n bar here. F bar dot n bar already from the third phase z is z. But here z is equal to how much? 0. Okay. Therefore, here f bar dot n bar z is z, but z value is 0. Therefore, directly here S4 phase f bar dot n bar ds is equal to what? Double integral of the x limits are 0 to a, y limits are 0 to a, that is 0 into ds, that is 0. Therefore, let us take that as the fifth phase. Okay, now we discussed how many phases. Two phases are on x-axis and two phases are on z-axis. Now I'll continue remaining two phases on y-axis, right? Okay, next. Okay, for S5. What is S5 here? Once you observe the diagram, PSCR, which is on the positive side of the y-axis, that limit points here y is equal to a and the unit normal vector is what? J bar. Okay, now I'm using the conditions for the fifth phase, that is S5 is equal to PSCR and y is equal to a and n bar is equal to what? Outward unit normal vector as J bar and ds is equal to what? Dz dx. Therefore, x limit points here 0 to a and the z limit points also 0 to a. Then okay, again take f bar dot n bar here. What is f bar? From the question x cube minus yz into I bar minus y square z into j bar plus z into k bar. From that dot, what is n bar here? J bar. Okay, then multiply both the matrices, that is here j bar coefficient as minus y square z and here j bar coefficient as 1. Okay, from that here minus y square z into 1. Wait, okay, here it is not y square z here 2x square y. Sorry, here for the question x cube minus yz into I bar minus j bar coefficient is minus 2x square y plus z into k bar dot j bar. Now dot product with both the matrices, that is j bar coefficient is here minus 2x square y and j bar coefficient as 1, that is minus 2x square y. Okay, from that here already we know that y limit point is what? A. Substitute there, that is minus 2x square into a. Therefore, this is minus 2ax square. Okay, therefore, integral of S5 f bar dot n bar ds is equal to double integral of x is 0 to a, z is equal to 0 to a, and what about f bar dot n bar? Minus 2a x square into dz dx. From that, integrate either with respect to x or z first. Here, first I will integrate with respect to z, that is minus 2a into x square into z. Z limit points are 0 to a into dx, that is x is 0 to a. Okay, that is minus 2a x square into a minus 0 into dx. Here x is 0 to a. From that minus 2a x square into a square, that is minus 2a square x cube into dx. X limit points are 0 to a. Okay, now integrate with respect to x, that is with respect to x means what? Minus 2a square into, okay, once you observe there x square only, sorry, x square, that is minus 2a square into x square, integration is x cube by 3. Therefore, the limit points for x cube here 0 to a, that is minus 2a square into a cube by 3 minus 0. minus 2a square into a cube by 3 minus 0. That is minus 2 into a power 5 by 3. Okay, therefore surface integral on S5 face, it is on y-axis positive direction. For that case, answer is minus 2a power 5 by 3. Minus 2a power 5 by 3. Next, what's the last face on y-axis? That is OBQA. That is OBQA. Okay, once you observe S6 on diagram, that is S6 is OBQA. Here, what about which is on negative side of the y-axis? That unit normal vector is what? Minus j bar. And what about the limit point for that? Z is equal to 0. Okay, then, okay, on S6 OBQA, for that case, Z is equal to 0. There Z is equal to 0, and the unit normal vector n bar is equal to minus j bar, and ds is equal to what? Dz dx. For that case, z limit points, here z limit points 0 to a and x limit points 0 to a. Okay, right? Here z is 0 and dy dz, sorry, there dy dx, ds is equal to dy dx, n bar is equal to minus j bar, and x limit points are 0 to a and y limit points 0 to a. Therefore, f bar dot n bar is equal to what? Already we know that here f bar dot n bar is equal to minus 2x square y. Okay, minus 2x square y. Therefore, here y point is 0. Here, sorry, OBQA on, sorry, here OBQA on y-axis negative side, right? For that case, y limit point as 0 and y bar unit normal vector as minus j bar. Y bar unit normal vector is minus j bar. Okay, from that, for that case, y is equal to 0, right? And n bar is equal to minus j bar. And ds is equal to, this is correct only, ds is equal to dz dx. X limit points 0 to a, correct? And y limit points 0 to a. Okay, this is the correct one only. Okay, what I discussed in the previous, that is not right. Here S6 is OBQA and y limit point is 0 and n bar is equal to minus j bar and ds is dz dx. And already we know that the fifth phase f bar dot n bar is 2x square y. And what about the y point here? 0. Therefore, 2x square of 0 is equal to what? 0. Therefore, f bar dot n bar is equal to what? 0. Okay. Therefore, let us take this as a seventh equation. This as seventh equation. Now add these 6 phases values, that is double integral of f bar dot n bar ds is equal to double integral of s1 plus double integral of s2 plus double integral of s3, s4, s5 and s6. What about the first phase one? That is a power 5 minus a power 4 by 4. And the second phase minus a power 4 by 4 plus third phase value a cube plus fourth phase 0 and the fifth phase minus 2a power 5 by 3 minus 2a power 5 by 3 plus 0. Once you observe here, anyone cancel? Here minus 2a power 5 and a power 5, that is 8. Second phase e power 4 by 4. This is third phase one, e power 4 by 4. Okay, then this a power 4 minus a power 4 by 4 cancel. The remaining a cube plus a power 5 minus 2a power 5 by 3. That is a cube plus 3a power 5 minus 2a power 5 by 3. That is equal to a cube plus a power 5 by 3. Okay, this is the final answer for the surface integral on 6 faces, that is a power 5 by 3 plus a cube. This is equal to what? Once you observe the first equation, that is triple integral value, divergence of f bar dv, that is also same. Therefore, LHS and RHS are equal from the Gauss divergence theorem. Therefore, divergence theorem is verified. Okay, this is the concept of the Gauss divergence theorem on the cube. For the first question is on cube. For example, okay, here the question is surface of the cube bounded by the planes. For example, in that cube, if they are given rectangular or square, means for that case we have to verify surface integral value on the four faces. Okay, four faces, and we have to verify LHS part and the RHS part from the Gauss divergence theorem. If the two are equal, therefore the Gauss divergence theorem is verified for the either rectangular or square. For the given question cube, in this case also Gauss divergence theorem verified. What is the final answer for that? A power 5 by 3 plus a cube. A power 5 by 3 plus a cube. Okay, this is the concept of the Gauss divergence theorem. Next session, we will discuss some other problems on the next topic. This is very, very important. Okay, thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.